Hey, it's the last segment, 30-1 of doing radian measure. So Mr. K might have been going too thorough, too slow. So if I was, make sure you play that and fast forward, make me sound like a chipmunk. Um, but there is a lot of stuff. It's kind of like learning French. It's a new language. And so the last part is, how do we use this and why did they use this? And one of the places that this is used is in calculating arc length. So if you think about it, measuring in terms of radians is much more powerful when you start, or when your interest is in arc length. So if you start thinking about rotation and so on, if I said to you, yo, this wheel is rolling along, and if it rolled through an angle of 154 degrees, and I said, well, how far did it travel, right? How far was the length of travel if this wheel that has a radius of 13 centimeters traveled through 154 degrees? An angle of rotation in degrees isn't very helpful, but if I said to you this wheel traveled through, instead of 154 degrees, if I told you that it traveled through 2.15 radians, then the question becomes very easy, because a radian is a radius, and if it went through 2.15 radians, how far it traveled would be 2.15 times that 13, which ends up being a nice answer of 2.15, whoopsie, 2.15 times 13 ends up giving us 27.95 centimeters. So much more powerful. This formula here is talking about that. We can rearrange this formula, but what's really important, and I'm going to say it loud, is that it only works when theta is considered to be in radians, and that's going to be important. This formula is when theta is in radians, and they don't put it there, but theta in radians is equal to arc length over radius. It does not work for degrees, okay? So be careful when you use this formula, but that formula can be rearranged, as you can see, in different ways. It can be arranged if you cross multiply in terms of A equals R times theta and so on, right? And those are the definitions of the variables. So let's go on to the next page, and I want you to try and use that formula, all right? So read the questions and try them on your own, and then come back and see the answers if you when you're done. All right, so we have a pendulum that is 30 centimeters long, so we draw a diagram. A pendulum that is 30 centimeters long swings through an arc of 45 centimeters. So it swings through that arc of 45 centimeters. That's nice. And the question says, through what angle does this pendulum swing? Answer in both degrees and radians. Okay, so there's my angle of theta. Well, I can see what I've got is I've got a radius of 30 centimeters, and I have an arc length equal to 45 centimeters. Therefore, if I use my formula, theta in radians is equal to arc length over radius, that's a pretty simple thing to do. 45 divided by 30 ends up being equal to 1.5 radians. But it also asked me to convert it to degrees. So theta in degrees, as it says, I take 1.5 and I multiply by 180 over pi, and I end up with 85.9 degrees. Nice. In question 2, I'm asked to calculate the arc length to the nearest tenth of a sector of a circle with a diameter of 9.2 and a sector angle of 150 degrees. Well, we need to draw a picture of that. What is that talking about? Okay, so I'm drawing it. A sector of a circle is like a chunk of a circle, like a piece of pie, you might say, right? So the arc length is what we're looking for of this sector. The diameter is 9.2, so that would mean that the radius of this thing is 4.6. So that's 4.6, and so would that be 4.6. This angle here, measured in degrees, is 150 degrees. So I could go to my formula and say, well, that's really easy. I have that formula. Theta is equal to arc length over radius. So I stuff in 150 degrees is equal to an arc length I don't know and a radius of 4.6. And then I multiply that together, and I end up with A is equal to 150 times 4.6, And then the words of Mr. K come back to me, not degrees. 690, good grief. How could that possibly be 690 centimeters? That seems way too big. And it is, because none of this is true, because we remember that this formula only works if I have this angle in radians. So I have to go back to the drawing board and do this right. All right, so I have theta in radians. I need to convert that 150 degrees into radians, and as I do it as an exact value, I go 180 degrees over pi. That converts nicely to an exact angle of 5 pi over 6. I want to keep it exact until the end. I'll round it near the end. It says nearest tenth of a meter. So now I've got my angle in radians. So theta in radians is equal to arc length over radius. So theta in radians, 5 pi over 6, is equal to A over R, which was 4.6. So that means that exactly my arc length would be 5 pi times 4.6 divided by 6. And if I multiply that together and simplify it, it ends up being, to one decimal place, 12.0 meters. And all is good in math. All right, so you need to be careful how you use that formula. And lastly, number 9, we read carefully and said a circle with a center C and a minor arc of 15.2 centimeters shown. And a minor arc is simply an arc that goes less than half of the circle. So this minor arc of 15.2, angle ABC, ABC is pi over 6. So that little angle right there, I'll just put a little line, that's pi over 6. And then it says if angle ABC and BAC, well, of course this angle is the same because it's saying that's pi over 6. Well, of course it is, because these are both radiuses. So that's an isosceles triangle. Find the length of the radius of the circle to the nearest tenth. Okay, well, we need to find those lengths of radiuses. But, I have this formula, theta in radians is equal to arc length over radius. I know the arc length. I'm looking for the radius. If only I knew the angle. But I can find that angle. This central angle is actually equal to, therefore, theta can be found by simply saying, well, I know that the whole triangle is supposed to add up to 180, which is pi. So if I take pi minus pi over 6 minus that other pi over 6 that we have, whoopsie, we end up with theta equal to 4 pi over 6, which is equal to 2 pi over 3. And if I go back to that formula, and I sub in the things I know, theta in radians is 2 pi over 3. The arc length was 15.2. The radius is what I'm trying to find. And if I multiply out 15.2 times 3 and I divide by 2 pi, I get an exact value for R. But to one decimal place, or nearest tenth of a centimeter, it is 7.3 centimeters. You are done radian measures. So that was a long lesson. And we'll see you next day where we'll work through the assignment. Great job, Math 30.